It's a yearly and submit. Okay, done. The first thing you need to do is just take the summary, descriptive statistics, because you need to know what is the number of observations just to see the skillet of your variables. Sum, I will use the import and export. So this is my 28 observations, the mean is this, standard deviation, minimum and maximum. Okay, numbers are not very high here. Sometimes you can see that the maximum number, if it's even in, let's say, percentage, it will show 6,000 something. Then there is something wrong with the data. You have to just clear it out again. That's what you're looking for. Okay, then first we have to draw. Let me make it bigger. Is big enough?
Yes.
TC line of export and import, how they are related, okay? Export and import. We will try to see in the graph how they go, because we know that the big difference between the export and import, if the export is more than import, it's good for the country. Why? Because the trade balance will be in positive, and your domestic currency will be stronger. This is belief, okay? We just press enter, and it should appear now. Now we can see from the graph, before 2000, we can see the import was high. So we had a problem with the currency, because the currency was first initiated that time, and it has some problem, and it did not get stronger. And if you can see here, trade balance increased here, here it became even larger, here, and it just high-rocketed here in 2020s. And it high-rocketed because of the pandemic, was the lockdown for 1 year, and export just boosted. When the borders are opened, and export boosted. But how they are correlated from the graph, what you can say? Positive correlation?
Yes.
Yeah, like this increase, this increase. For us to understand this discrepancy, how much it will be differentiated and bigger. Okay. Now we can understand there is some correlation with the data. First, we understood that this is data in absolute terms. We need to convert into natural logarithm. Like we generate series. Let's say we start with Lx, which is log of exports. We generate series for imports, Lm. So we created logarithm of export, logarithm of import. Then we need to test for stationarity. In time series, it is better to test using the augmented decay Fuller. Okay, it's here. You can go from here, but I'm gonna give you the statistics like tests here. Here, augmented decay Fuller unit root test. You can go from here, but if you just type like T Fuller Lx. Okay. Oops, my bad. I used the small letters. I have to use the capital letters. So that shows my export is not stationary. I will do the same thing for import. Same. It's not stationary. And if it's not stationary, we said that data, if it's stationary, that it means that in the long run they have a relationship. Now we can see that they are not kind of cointegrated, but we need to make a deeper test. So we need to take the difference. As you remember, difference, and I was told it's the first step how to make the data stationary. It is to take the difference, like from the current, subtract the previous result. Like 2023 minus 2022. And continue with all the variables. You take the difference, and taking the difference will reduce the number of the observation. Same thing, like you are making decay Fuller, but we are with one addition, like y dot differencing. So we can see taking one difference means that it's a stationary of integrated order of 1. And there is a condition for the variables to be stationary and to be cointegrated in the long term. they should be integrated of the same order. Sometimes variables, one variable is integrated of order 1, the other one is integrated of order 2, which means that one variable could be stationary at D1, the other variable will be stationary at D2. So I can make D2 here, like D, it says that it's a D1, but you can make D2 by adding 2 here, and it will be highly stationary. So if you make it D3, there is no way to make it highly stationary, it's already 0. So it could be the case that the one variable could be not stationary at even D1. So you need to go for D2. But in here, D1 still is okay because it's highly stationary too. So now I'm going for import. So still stationary, but at 5% of level significant. If I make D2 here, it will be highly stationary. So I don't make it, I just accept this. Like it's integrated of order 1. Integrated order 2 means you're taking difference of order 2. Okay, now we can measure the long run relationship. Just make a regress. So regression analysis is basically measurement of the long run relationship. Like export will be our dependent variable and import gonna be our independent variable. So here, we can see that increasing import by 1% will make your export to increase by more than 1%, which is by 1.20%. So it shows the speed of adjustment of your export in relation to import. You see how quickly it goes, and from the graphical representation you can see the difference between the export and import. It goes by 1.20% faster. And now we can see that there are two ways to understand it here, whether this export and import cointegrated. One using the error term, second using the grandeur causality or angle grandeur method. So we'll start with the error. So first of all, we need to derive from here, from this regression analysis, we have to derive the error, the residuals, which we do like with the prediction. Predict, we will call it error. You can call any type, but predict, error, and residuals. So as you can see on the right side of the box, the error appeared here. Now we can get this, the mean. So we need to get the mean of the error term.
Where is error? Ah,
here it's appeared.
Ah, okay.
It's here. And from here, once we have estimated, we need to get the mean of the error term. So sum error. So this mean we need to get it. I'll copy it, and I want to put into the graph, and I want to see how it deviates around this mean. Is it so far? In order for the variables to be cointegrated, the variation should be very, very small around the mean. I'll just show you, like TC line, error, and Y line, it's kind of mean, and I'll put this number. Error type, error. So this is the mean that we created, and this is the variation. So this variation should be very small in order to show that there is a cointegration between the export and the import. If it's highly deviated, then the probability that there is a cointegration is very low. So the error shows that the deviation is here, but later it comes back. But it takes longer here, and here, but in here it is quickly getting to the mean side. Okay, then we continue. We go here. Now, as I told you, to understand through the error term whether there is a cointegration between the export and the import, we need to take the stationarity test for error. If it's if our error will be stationary, that shows that there is a cointegration between the export and import. Again, if Dickey-Fuller test will show that our error term is stationary, that will prove that there is a cointegration between the export and the import. And this will be the first method to prove that there is a cointegration between this, which means you can now make a regression analysis, export on the import, and prove it that there is a cointegration, that there is a relationship. This relationship is not by coincidence, that it's proven here. Is it clear why we are going for the cointegration? Okay. Does that everything is okay? Okay. So we go D Fuller error, and the error should be no constant variable. With no constant variable. Okay. We get this t statistics, and there is no like p-value given here. In error, it doesn't provide any p-value. You can compare with these values, but they are not real ones because they are derived from our regression model, which is not observable. We need to compare with the cointegration table, which I provided in here too. It's here. Oops, doesn't work. I have to go to drive. Here, cointegration table. Okay. So here the critical values. If your compute t statistic here, for the error term to be stationary, your t statistic should be more than critical value, one of the critical values that are given here. And we need to compare the how many observations we had here? 28, yeah? So we select the closest. We're not gonna go for 100, we're gonna go for 50. And we have two variables. You can have 4 variables, you can have 5 variables. In this case, we have only 2 variables. So we are using 2 variables, closest here, and the critical values we're gonna be using here. So our t statistic is like 3.79, and you can compare. It is less than 1%, it is more than 5%. So it is stationary at 5%. So which means there is a cointegration between export and import. Okay, then we move further. The first way, we have proven there is a cointegration through the error term. Now we need to go with another way, which is Engel-Granger method. Engel-Granger method has divided into 4. Even, my bad, there are even more than 4 cointegration tests, and the Engel-Granger is one of them, and is like the first, like the father of the cointegrations, we can say, test. And we're gonna go with that. There's a Johansson, there's a Phillips, there's a Gregory Hansen, but we're gonna go and Engel-Granger, okay? So to do that, we go like find it, because it is not installed here, we need to find it. Granger. So it's here. I just press on that, and here I can install it. Okay. So here, complete installation. Now I can run it. Granger LX LM. Of course, my bad. Now here we are not given p-value 2, but we don't have to compare with the critical values which are given table. We can compare with the values that are here. This one should be greater one of the critical values. If it's greater one of the critical values, then we show there is a cointegration. They are cointegrated. Okay, bit export. So it is greater than 10%. It's greater than 5%, but lower than 1%. So at 5%, they are cointegrated. So there is a cointegration. This is the second method that shows there is a cointegration between exports and imports.
We do not use table here, we just compare.
No, we compare. The table we used for the error because the error was derived from the regression analysis. It's just, it is not observable. But here, the data is observable. We collected this data and we are using this data. So the critical values can be trusted here.
And should we run for these two methods or?
Yeah,
now
for
one?
two.
So this is higher than 5%, so it's
Whatever I just did it here, you will do the same thing. Okay, now the last one, what we do here, we try to measure what we did it up to this point. We measured the long run relationship, but let's see how they behave in the short run, and how long it takes for this relationship to get into the long run relationship. Okay, so regress. It's DLX, DLM, and the error term. The error term will give you the speed of adjustment, the speed, how fast it will converge into the long run from the short run. But we need to take the log of the previous error. Here we go. Now, this is the short run condition. We can see in the short run, increasing 1% in import will increase by 1.4% or by almost 1.5% your export. So we can see the export is highly sensitive to the changes in import in the short run in comparing to the long run. But in the long run, it becomes more steady, but still it's increasing higher. But in the short run, it increases faster. But we know that the short run is not forever. It's not lasting like all the time. How long it will be like this? How fast it will converge into the long run? This can help us to see the error term. This shows that for the error term, it should be from -1 to 0, the coefficient. If it falls within this range, the model that you have estimated is correct, is good one. If it falls beyond these numbers, like this coefficient, if it's like somewhere out of -1 or before the 0, then there is a problem in your model. You have to re-estimate. You have to change the model. You have to try to other things. Maybe you go with a difference of 2, second order. So in here we can see it's like very good, and that it shows that it is statistically significant. This is important too. And the speed of adjustment is 88% here, which means that it will take less than 2 years to converge into the long run. Like 88% in 1 year. Imagine if it was like -1, it means 100%. That means in 1 year it will converge into the long run. So that means that your imports will increase by 1% in the short run, the export will increase by 1.4%, and this increase will be only lasted for more than 1 year, but less than for 2 years. In 1 year, it will converge to the long run. This is what it means. Okay? Long run equilibrium. Do you know what does the long run equilibrium means? When economy works in equilibrium, it's good. When there is no equilibrium, there is either shortage or surplus, which is really bad. That really squeeze the economy. All economies, they work in the long run. Equilibrium. Normal economies, like if they're normally growing. If not, there's a big problem in the economy. So basically, this coefficient determines the speed of adjustment. Like how fast the short run converged into the long run, which is corrected by error correction term. Okay, so this is it that you need to know.